Dear students, today we are going to talk about the parallel and series combination of resistances. You see, resistances can be kept in two distinct ways together. One is called series combination and another is called parallel combination. In series combination, what it is done? Head of one is connected to the tail of another, and so on so forth. That becomes a series combination. It means that some current, if it is flowing through the first resistance, same current I, in this case we have taken I, same current will enter into the next resistance because there is no way out. Charge can go neither way except going into the next resistance R2 while coming out of the first resistance R1, and then the outcome of the R2 shall be entering the next resistance R3, and so same current will be flowing through each resistance in case of a series combination. That is the binding test for the series combination of resistances. Here you can see resistances are different, so we can have different potential drop across each resistor, and therefore we can have the individual potential drop, sum of individual potential drops across R1, across R2, across R3 being V1 and V2 and V3. All these together will give the total potential drop across the end AD, and therefore the total potential drop across the series combination will be equal to the sum of individual potential drops, that is V1, V2, V3. Now, using the relation V is equal to IR, the Ohm's law, we can have total potential drop across AD if this could be taken as an equivalent resistance. Let us say this is an equivalent resistance, and we have to find the resistance across AD. Then the potential drop across AD will be nothing but equal to current flowing through AD, and since same current is flowing through each, so we have to write again I, and that multiplied by R series resistance. So that means for V we can write IR resistance and IR series, and then for V1 we can write IR1, for V2 we can write IR2, and for V3 we can write IR3. So I on the both sides, when we take the I common on the right hand side, cancel with the I on the left hand side, so we are left with R series is equal to R1 plus R2 plus R3. So this is the expression for series equivalent resistance of series combination if there are three resistances connected in series. Now similarly we can talk about parallel combination. In parallel combination, what we do is we tie up together the heads of all resistances and their tails separately and connected together. Then that combination will be called parallel combination. In this case, what you see, all the heads are connected with one end and all the tails are connected at another end. In this case, if some current is allowed to pass through the series parallel combination of the resistances, this current I, let us say we have taken I current entering the combination, will be distributed in the three arms of the resistances R1, R2 and R3, and we call it I1, I2 and I3. So therefore we can very well write according to the principle of conservation of charge. So charge flown per second will also be conserved, that means current will be conserved. So that means I is equal to I1 plus I2 plus I3. So we have written I is equal to I1 plus I2 plus I3, and now using the relation V is equal to IR, that is I is equal to V by R, we can write V by R parallel combination is equal to V by R1 plus V by R2 plus V by R3, because for I1 we can write V by R1, for I2 we can write V by R2, and for I3 we can write V by R3. and here you see the equivalent, the current flowing through the combination I will be equal to the potential drop across the combination divided by equivalent parallel resistance of the combination. So here you see, when we take V common on right hand side, it cancels with the V on the left hand side. So we are left with 1 R parallel, 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So in this case, what you see that they are reciprocals, sum of the individual reciprocals of individual resistances is equal to the reciprocal of the equivalent parallel resistance. And in this case now, as we have seen in case of series combination, that same current flows through the each resistance. In this case we see that same potential drop happens with the each resistance in the parallel combination. Potential drops across each resistances are same, current flowing them are different. But in case of series combination, potential drop across the resistances may be different, but current flowing through them is always same. Thank you and have a nice day.